The first thing to learn about differential calculus is to reassign y in terms of x. For example, we have this equation y is equal to 2x plus 1. So this is the line for our equation. We have a point xy in the graph. But since we know that y is equal to 2x plus 1, we can now rewrite this y as 2x plus 1. So we can now put this 2x plus 1. So we don't have to write the y anymore. So y is now in terms of x. Y is 2x plus 1. But sometimes the value of y is so long that we cannot put it here. So we can rename y as a function of x. We just rewrite this y as a function of x. It means that the y is in terms of x. So this one now becomes a function of x. Function of x. So whatever is the value of y is now in here. So that's the first thing we need to learn. Next, the primary purpose of differential calculus is to find the slope of curved lines. For example, we want to get the slope of a line tangent to a curve at the point xy. So this is xy. This point is xy. We know that but we need 2 points to determine the slope. So we can add another point. We can add another point very, very close to x, so that we can have 2 points to get the slope of that line. I would like to magnify these 2 points. You can barely see those 2 points. Let's say these are the 2 points. This one and that one. So this is actually, these two are very close. Now this first point, this one is, let's say this is x. And now the distance between this one and this one, let's say this is h. But this one h is very, very close to 0. This is very small. So this is now, we call this so this point is x1, y1. And now this point, so this is a distance of x, h. This is the distance of h. Now this point is now x plus h. Because this is x, this is x, and this one is x plus h. Now the y, of course, is y2. At the moment, we'll just retain the y. So this is x, and this is x plus h. Now we need to get the slope of this one. This is the line tangent to the curve. So the slope of this one would be this. This is the rise over the run. So that would be the slope of that line. Now if I will just now rewrite this one, x and y1, x plus h, y2. So we'll just rewrite it in here. So this is x, this is x plus h. But instead of writing y, we will use this renaming system. So this will become x. This is still x. But this one, instead of y, we will write the function of x. This point is x and the function of x. Now this point is x plus h. So this point is x plus h. Now the y is also a function of this. So it would be the function of x plus h. Now, if you would remember, so we are getting this slope. We now have 2 points. So because we have 2 points, we can now use the formula for the formula for the slope. So what is the slope? Slope is the rise over the run. Rise over the run. So this would be, so remember the slope in previous math subjects is y2 minus y1 over x2 minus x1. In this case, the slope is this one. So this is the change in y, or over change in y over the change in x. So this is the change in y, but since it's very, very small, we call it dy, change in y over the x, change in x. Now, let us now use these points to get the slope. So we can now rewrite the slope as y2 minus y1. So y2 minus y1. So we will rewrite f of x plus h minus, this is y2, this is y1, this is x2, this is x1. So y2 minus y1, so f of function of x plus h over minus f of x over x2 minus x1. Our x2 is x plus h. So x plus h minus x1, which is x. So minus x. Now, so if you, this one can be subtracted, x minus x is equal to 0. So we can rewrite this now as f x plus h minus f of x over h. So this is the slope, but since it is very small, let's rewrite this as d. So dy, it's better to use dy over dx. So this is the slope, very, very small, that's why there's a d. So this is now called the difference quotient formula. Difference quotient formula. We can now use this formula to solve for the slope of any curve. So here is an example. Find the slope of the curve y is equal to x squared. So like in previous discussion, we will rename y as a function of x is equal to x squared. So function of x is x squared. Now in our formula, we have the function of x, we have a function of x plus h. Now this is the function of x. The function of x is x squared. It means the x is squared. Now the function of x plus h, this also have to be squared, x plus h squared. So we now have the function of x, which is this one. We have the function of x plus h, which is this one. Now we plug it into our formula. The function of x plus h is x plus h squared minus the function of x. Our function of x is x squared all over h. Now if you square x plus h, it will be x squared plus 2hx plus h squared. So that's, this one becomes this one, minus x squared all over h. Now x squared minus x squared, this will cancel out. So what we have left is 2hx plus h squared all over h. Now we have h on both terms. We can factor it out. So we have h. So what we have left is 2x plus h all over h. Wait, this is h. We factor out the h. Now this h in the numerator and h in the denominator, we can cancel out. So what we have left is 2x plus h. Now if you would remember that h is very close to 0, we can have this one get to 0. So our slope is 2x. So that's our slope. This is our dy over dx. Our slope, very small change in y over very small change in x, is 2x. Now you will notice the slope has a variable. There's an x. This is because every point in the curve has a different slope. So for example, so this is your curve. Now every point that is tangent to the curve, every line that is tangent to the curve, the slope would be different. The slope in here would be different from here. This will be more steep. So every point will have its own slope. So that's why we have a variable. For example, we want to get the slope on 1, 2. So we want the slope on here at x is equal to 2. So the slope at x is equal to 2 would be, so you replace 2 on x, so 2 times 2 is 4. So the slope at this point is 4. So another example, for example, so this x is like 3. So 1, 2, 3. So at x is equal to 3, at what's the slope at x is equal to 3? The slope would be, you put 3 in here, 2 times 3. The slope at x equal to 3 is 6, or 6 plus 1. In here is 4 over 1. This is the rise over the run. Rise over the run. So you have different slopes on different points of the curve. One final thing about the slope of a curve, about the difference quotient formula. We have this example, f of x is equal to x squared. When we solve for the slope, dy over dx, the final answer is 2x. Now this is the original equation, and we were able to solve this x to the first power. It doesn't have it. Now we will now analyze this from here to here. What happened? To generalize, so the x squared became x to the first power, and then whatever the power in there, it went into the front. So we can make a shortcut for the difference quotient formula. So what happened is, if you have the x to the n, x to the n, like this is your f of x, the shortcut, so the n will go to the front, so it becomes n, and then whatever the exponent, you have to subtract by 1, so x to the n minus 1. This will be your slope, your dy over dx. So this is now called the power formula. Power formula. You don't need to do the difference quotient formula because there is a shortcut. No need to do the long method. Use this formula to solve for the solve for the slope.